Hi, and welcome to this lecture on decorators. In this lecture, we are going to learn about what decorators are, how to use them, and some common errors associated with them. So let's go ahead and open up our script editor. Okay, we'll click in the viewport. We are going to press and hold the spacebar. We are going to go down to panels. Okay, 5 up from the bottom. Click on script editor. All right, we can clean out our output window at the top, or you can do both windows by clicking on the double highlighted box with a cross. What are decorators? So in Python, decorators are a way to modify and enhance behavior of a function, method, or a class without changing its source code. So decorators are essentially functions that take another function as input and they return a modified version of that function. Decorators are defined using the @ symbol, okay, followed by the name of a decorator function, okay? So when a decorator is applied to a function or a method, the original function is replaced with the modified version returned by the decorator. Let's have a little look at an example within how to use them. Okay, so here's a little example of a decorator that adds some functionality to a relatively simple function. So we've got down here our functionality. Here's our decorator, my decorator. We've got our function, which we're defining, which is called say hello. Open parentheses, doesn't take any arguments, and then we print hello. So if we just initiate this by itself, so by highlighting the function and pressing Control and Enter, and then we press Control, highlight, say hello, and press Control and Enter again, we'll get hello. But let's highlight and again run our code. So we're executing our function myDecorator, which takes the function, which here we'll call sayHello function, but this again could be any name because we're passing the argument to it. So this could be the sayHello function, okay, which you'll see here and here, or this can be quite simply just the function that you put in, which is normally best practice. Thought I'd do this for illustrative purposes though. So again, we've got a function, myDecorator, which takes our function, and then we've got our functionality, which we're going to add to our function. So, all right, let's run everything and see what happens. So in this example, the myDecorator function is defined to take another function as input. It returns a new function that adds some functionality to the original function with the myDecorator decorator. Sorry, should have maybe named that something else. But the syntax is used to apply the decorator to the sayHello function here. So a function is passed. We've got our functionality here, but we're running we're running a few prints before and after. So we've added some functionality while still running the sayHello function. So when sayHello is called, the decorator is invoked first. That means the decorator runs before the function and prints the before the function is called string. Function is then called, we'll see here with open parentheses, and then straight after the function print is then called. So this shows how the decorator has modified the behavior essentially. We've passed our functionality. We've then got our wrapper inside the decorator, and we are then printing before and after the functionality. So decorators are commonly used in Python for a variety of purposes, including logging, authenticating, and modifying the behavior of methods in a class, or creating custom decorators for specific use cases. So let's have a look at maybe another example. Down here, we've got our functionality. We've got our add function. All right, so we're defining add. It takes the arguments A and B, positional arguments, and they return A plus B. So we've got our result down here with add 2 and 3. All right, and we've got our debug decorator, which again could be just added if you find you've got an issue, let's say, for example, with a certain function. So let's have a look at what's going to happen. So our function is going to be passed to our debug decorator, which again has just been added right before our add function. And here we've got our wrapper. So this is where we place the arguments. If you want to look back, you can remind yourself what these asterisks mean before args and keywargs. Essentially, this is unwrapping all of our arguments, our positional arguments, into a tuple. And the keywargs with the double asterisks is unwrapping all of our keyword arguments into a dictionary. Let's have a look. Now what's happening? So before and after the function is called, the function has been called all the way down here. But to debug this, this function, we're going, well, what's the name of the function? And again, we've got another one of our magic methods here. Got func dot double underscore name double underscore. I'm going to say you can guess what's going to happen here. It is essentially just going to print out the function name, which will be add. We've then got arguments, args, which will print out the tuple of our arguments, which will be 2 and 3. Keyword arguments, which will be none, or an empty dictionary essentially. And then we are going to get the result from our function by passing the keywargs and by passing the args and the keywargs. And then we will print the result for, again, the user output, and then return the result. So we'll still be returning the result, which will then be returned via the decorator. Okay, via the decorator through to the function, which will then be returned to the user. Sorry, that was a bit in depth, but okay, let's just run it and see. So highlight it all, press Control A, and then press Control Enter. We've got our debug decorator. Everything has been executed. So we have entered debug decorator into Python. We've also entered add with the debug decorator above it. And let's see what we print out here. So we've printed out calling function, add, functioning name, function dot underscore name, our magic method. We've then got the arguments, okay, which is our tuple of 2 and 3. Our keywargs, which is an empty dictionary, and the result, which is 5. So again, you can see how these decorators can be quite useful. You've got all of this functionality here, which will, again, give you quite a bit of information. And what you can do is just put this one little decorator right above of your function, not changing it at all, and it adds functionality to it. It's quite a powerful little thing. It's great. So the property decorator is one of the most commonly used decorators, I think, in classes, though, probably. So let's have a little look here and see, okay? It can be used to create essentially a read-only property for an attribute in a class, which means that when you access that attribute, you can get its value, but when you try to set its value, it raises an error. So let's have a look at an example of this. Let's clear out our output window. So here's our new class. We've defined our init. Again, this is our function with the magic method, essentially as a built-in method of a class, which is run right at the beginning of a class being initiated, which can take its arguments, and then you can do as you will within that class. So right here, we're going to assign a class attribute as underscore value. And again, we'll talk about the underscore shortly, but hopefully you remember what that means. But let's talk about our property decorator here. So we've got value, and then from this we return self.value, which we have entered into our instance of the class here in self. We are now returning self.underscore value. With dot notation, we can quite easily access this. So let's access. Let's go. Highlight all. Can't set attribute. Oh, okay, I erased everything. So I ran through a little bit quickly there. Let me just do the beginning part. All right, so what have we got here? So we're printing object.value, okay, which is again dot notation. Okay, this isn't now a method, where this has been made into a property or an attribute essentially. So we don't need to do open brackets because this method now has become an attribute, okay, or a property of this class. And we'll see it outputs 10, just as we've stated. But now let's see what happens if we try and assign a value to the value method here. Yeah, we get our attribute error as we just saw a minute ago. We can't set the attribute, all right? We haven't given ourselves the way to do it yet. Price is now essentially protected. That is, or value is now essentially protected right here. And it's considered protected because we added the leading underscore to its name, self.price. But again, Python would allow you to change that unless we added the property decorator. The property decorator is essentially the getter of this method. It allows us to get the value that we have entered within our class, but unless we specifically state a setter, we aren't allowed to actually set this. So this is our getter, and now we're going to try and create a setter so that we can actually set the class, okay, or set the property. Again, let's have a little look at doing this. So let's use another example this time, and I'll show you the getter and setter attributes of the app_property method. And these will allow us to create a read, write, and a delete functionality for the attribute. So let's add this in. I might have to zoom out a little bit here so we can see all the code. But we've got our car class. We are initiating with a price with an underscore below, signifying to a developer that this shouldn't be accessed outside, okay, of the car class. But we have now got our property, okay, which is price. So this is our getter. You see, we've even put in the docstring just to make it easier for ourselves, okay, with self.price. And we've got our price.setter. So we've actually here called price. We're using some more built-in functionality in Python, and we are giving this the name of setter, okay, or we're saying .setter. So we're using dot notation and saying that this item, okay, is using the decorator setter essentially with the price attribute or property. So again, we just call this definition price because again, it's more important about essentially what this is wrapping, which is price.setter. And then we can say, okay, self, we're taking the instance of the class, and then we're taking in the new value or the new price that is being passed over to this. And so we'll say, well, if the new price value is above 0 and is instance of a float, so, okay, maybe this should probably be actually a float and an int because it might be a rounded number. Okay, it doesn't matter if it isn't. All right, let me copy that back to the notes so that you can have this to look at in your own. And if not, it says, and if it isn't either an instance of a float or an int, okay, and is not above 0, okay, because you're not going to obviously sell a car for less than you paid for it, or if it's less than 0, then it says, please enter a valid price. Straightforward. And then right below that, we've got add price deleter. So again, we're now decorating the price property with a deleter. So if we try and delete this outside of the class, then this is the functionality that will run. We won't just necessarily delete it, but you know, we can set the functionality we need. So, okay, let's press Control A and then press Control and Enter. Not the best naming here. Again, it's lowercase, so it won't overwrite our uppercase car class, but we should probably call this something a little bit less risky. But okay, let's create our instance of our class. All right, which is worth here £10,000. Okay, dollars, rupees, yen, anything. Okay, that you'd like, or any currency that you'd like. Okay, now we're going to set the car price here using our setter. So car.price equals 6,000 actually. Okay, now we're going to essentially call it using the app property. Okay. And now it's set, okay? It's been set as 6,000. We've got the price, okay? And now what we're going to call is our deleter and do delete car price. So if we now go for car price, what we're going to get? Ooh, car has no attribute underscore price. All right, now, okay. I would say the main problem, I'd say this is pretty good. Okay, this shows you what happens now if you use the delete functionality on a class. Essentially, we're using the attribute, the deleter. But let's say you want the delete functionality to work a little bit differently. Let's say that if somebody does say delete, then instead what you do is you set the car price to 0. You may not want to actually delete the variable. You want the variable still to be there and still be settable. Otherwise, you're just kind of deleting the only piece of information this property has. But you can do anything you want. You don't have to call this and say delete. Okay, that might be what you need to do, but you don't have to. So let's reinitiate this now. Okay, we'll go through and we'll initiate the car at 10,000 and we'll set it to 6,000. As we've done here. And now if we call car price, again, highlighting, press Control Enter, it's 6,000. But now if we delete car price, and then we look at car price again, it's just 0, okay? So you see, although we're deleting it, okay, Pythonically, we're actually, again, doing what methodology we need and what best suits our functionality. And I think that that's probably what you should take away from this, is that obviously we're not just setting now, we're actually adding functionality. So if we didn't have any of these methods, and we just had price here, okay, then this is saying, well, basically just do all of this, okay, here. All right, we don't have to use the getter and the setters and the delete. But what they do is allow us to add functionality to those methods, okay? So as we've got here, we can now check if the price is above 0. We can check if the price that's being passed is an integer or a float, and then pass it, and if not, give user feedback. So I'd say that this is adding usability and functionality which will save us time as a developer, especially if this is a user-facing tool for non-technical staff. You want them to be, you want to sadly, or you need to write more code to sometimes make your scripts, stupid proof. Okay, not to call the people that you're working with stupid, but to say that they might not understand what you've written because, they've not been there while you've written it. So you need to make your scripts bug-proof, or you need to, again, give a little bit of information back for when errors occur, because they will occur. But again, if this is all you need, this should be fine. We've got our car. Got our car price currently, which is 10,000. We can still set it to 6,000. We're still, it's got all of our functionality that we need. And now if we access car price, you see we can't get it because it doesn't exist. So essentially, instead of doing all of those default functionalities, we've essentially just, we've hacked them. We've added functionality to them and to those methodologies of the class ourselves. And you can basically do that for every part of a class, the iteration, what it's returning. I've made these for lists where I actually wanted to create an object list for meshes, but when the return was passed with a loop, that the loop automatically classified them into a nodal setup. And that was, again, really useful for me, okay? It made sure that every time I got a loop of a mesh type, that I had a very usable object that gave me a lot more functionality without me having to specifically assign each mesh type to being a DAG type. Okay, these are really cool functionalities. But again, if you don't need them, hey, 3 lines is enough sometimes, okay? It's very much up to the scope of the project you're working on. And again, a lot of the questions that you should ask before you write a code. Who's going to be using this? Okay, how difficult does this need to be? What kind of feedback do I need to give to the users? A lot of questions that you need to ask when starting a project, which again we'll go into later on in best practices. We'll talk about this stuff. Yeah, I think that's everything I want to say. Let me have a quick check of my notes. I think I've covered everything there. But okay, let's say we've now got a new class called myClass. Okay, we've got another property, we've got another decorator, okay, which actually is called a static method, another built-in decorator within Python, within classes. And this allows us to essentially use methodology without having to first call the class. So you see before we were having to essentially run our class, pass some information to it, and then open it well. What this static method allows us to do is to access functionality within a class without having to initiate that class first. So you'll see there's no init here. Well, there's also no self within this within the static method. This because this static method here isn't aware of any other method. So if we have another method, add See, add does have the understanding of other methods. If there's another 12 methods there, and we do have an init, then add would be able to call them, okay? If we call the functionality add by itself, and we wanted to access the initiated variables of self.x, okay, and self.y, we can do that because we understand we have the instance of our class, okay, passed to add. But with static method, we don't. Just a bit of an example there. Let's have a little look. 7, easy. Okay, we've added 3 to 4, and we've done that without first having to initiate our class. So the myStatic method is a static method because it is decorated with the static method decorator, and for no other reason. This means that it can be called on the class itself rather than on an instance of the class when the method is called using the class name myClass.static, my_static_method. It takes two arguments, x and y, and it returns the sum x and y, in this case calling static method with the arguments 3 and 4. Okay, let's have a little look now at some common errors. So hopefully these are making a little bit more sense to you if you see these decorators. A really easy one is not returning the result of the original function. When a decorator modifies the behavior of a function, it must still return the result of the original function to the caller. If the decorator does not return the result of the original function, the original purpose of the function, it'll now be obsolete. You won't have any information to work with that original function. So it'll essentially have just destroyed it. Not handling exceptions correctly. If the decorated function raises an exception, the decorator may not handle it correctly, or it may swallow the exception entirely. But to avoid this, the decorator should catch any exceptions raised by the decorated function and either handle them appropriately or re-raise them, essentially. So, overusing or misusing decorators. I haven't seen this too much. This is because, I mean, most people are it's just obviously a little bit of an overhead of writing them, and you have to really understand them properly. So you don't see these too often, especially not sadly within many rigging disciplines, especially within the smaller studios. Once you start going up to bigger studios, you'll start seeing a lot of decorators being used because they have very much professional IT teams and software developers writing the code there. Okay, so you will see them in those places. But decorators can be a very powerful tool, okay, in Python. They can also make code harder to read and understand, though, if used excessively or inappropriately. Okay, it's important to use decorators, appropriately and in the right scenario. Okay, and where necessary, to solve a specific problem. Like I said earlier, with the myCar or with the car class, you can do all of that functionality through the getter and the setters, but you don't necessarily need it. Okay, there's maybe then to think, you're going to cost yourself 20 lines of code and code that has to be maintained and read. And if it's not going to help anyone, then yeah, don't bother. Let's try and think of an example here. So not handling exceptions correctly. Let's try and think of an example for myself. Within one of my math modules, I have a series of about 20, 30 math equations that all take essentially an integer or a float. So I've essentially got a wrapper within that module, and it just checks that each one of those functions is being passed integers and floats. It's essentially a nice quick way. I've then got the wrapper after each one of those functions. Each one of the functions themselves within the math module are about, I'd say up to 7 or 8 lines long at the most. But it allows me to check all the args and make sure they're integers or floats. And then if not, I raise the error in that one wrapper rather than raising the error in every one of those functions. Again, there's 20 to 30 functions there. Why would I want to write the same raise error for each one of those functions when I can raise it in one wrapper, which is then a decorator for each one of them? And because that decorator is right at the beginning of the module, it's actually very clear for the user that, okay, I've got a decorator here that raises 2 exceptions if the value error is there, or if there's a specific type error. And this is very useful because then I'm only raising them in one place, but then you see that decorator name scattered all below in every one of the functions because that module has very specific functionality. So yeah, again, so although this can increase difficulty with readability, this can also decrease it. And just remember that, okay? Obviously, it's better to have 1 or 2 exception handling statements rather than having 30 or 60 if I'm going to do 2 in each one. Why would you want to write 60 when you can write 2? It would be madness, wouldn't it? So yeah, just remember there's always a case and a scope for what you're doing with these. All right, great. So in this video, we've learned about decorators, okay, what they are, how to use them, and we've learned about some common errors, okay? Thank you so much for listening, and I'll see you on the next video.